Hello everyone. So today we will be discussing today's LeetCode daily challenge problem. So the given problem statement is it is saying us to find a number which is occurring only once in the given array. Like in the given example, first example, we can see 2 is appearing thrice, but 3 is only appearing once. So we need to find such a number whose occurrence is 1. In second example, 0 is appearing thrice, 1 is appearing thrice, but 99 is appearing only once. So the answer for this test case will be 99. You can see the constraint, it's of 1E4 order. Now we have also been said like each element appears exactly 3 times except only one element which appears once. So they are asking us to implement the solution with linear time complexity and use only constant extra space. So if we try to think of a brute force approach here first, which will be of O of n square solution, like what we'll do is we'll every time see first number 2, and from this 2 I will be seeing all the rest element like 2, 3, 2, and I will be seeing if this first element is equal to the next element, like 2 is equal to 2, then I will be incrementing my count 1. 2 is not equal to 3, I won't be incrementing. 2 is equal to 2, I will be incrementing. So here the count will be 2, and initially I will be taking count as 1. So my count will be 1 plus 2 equal to 3. That is, we came to know that 2 is appearing thrice. Then again I will come to this 2, and again I will be saying 2 is equal to 2, 1, 2 is equal to 2, 2, 2 is equal to 3, no, 2 is equal to 2, 3, yes. So yeah, this will be a brute force approach which will be of O of n square and which won't pass because the constraint are of 1E4 order. So we need to optimize it. So further we can use map data structure for this. Like we'll keep the frequency, like for 2 it's appearing thrice, 3 appearing once, and then just we'll iterate over a map and find which element has its occurrence as 1, and I will be returning that in my answer. So what will be the time complexity? In this case the time complexity will be of O of n, but I am using additional space here, so which will be of O of n order only again. So yeah, that will be accepted, but that's not the best way to do this question. So now let's discuss the most optimized method to solve this question. So basically we will be using bit manipulation logic to solve this question in constant extra space. So basically we have been given that every element appears thrice. So if we consider first example and represent every element in form of bits, so what we can find is, let's see, like 2, I can write 2 as this, 2 again, wait a second, 2, 2, 3, both bit are set, again 2. So yeah, these are the 4 numbers I have represented it. So basically what I will be doing is I will be going on every bit position and I will be counting the occurrence of every number, like how many times 1 occur. I will be seeing just that only. Like I will be first iterating on the 0th bit. So what I'll find is 1 has occurred only once. So if it would have been in a group of 3, then it should have appeared like 3 times or 6 times or 9 times and so on, because every number will be having that bit as set. So we can say that if that bit is not appearing uh, thrice, like in a multiple of 3 order, then it's definitely clear that the number which occur only once has that bit position as set. So if we see here, we can see that 1 is appearing only once. That means uh, it is not divisible by 3. 1 modulus 3 is equal to 1. That means the number which has occurred only once, we will be having this bit as set. So what we will be doing, we will be initializing a number in which we will be setting this bit on. So yeah, it's 1. Now I'll be coming on first bit position. I'll be seeing how many times 1 occur. Like I can see 1, 2, 3, 4. Again it occur 4 times. That means it is not appearing in the order of 3 multiples. That means this position is also set of a number which occurs 1. So yeah, now I can see this number is nothing but 3. So I'll be returning my answer as 3. So that's correct. Let's see one more example. Like I have this example 4, 4, 4 and 5. The answer should be 5 here. So I will be coming on 0th bit position and I will be finding that 1 has occurred only once. That means this position will be set of a number which has occurred only once. So I will be setting this bit on. I can see here no 1 occur. That means this is correct. Let it be 0 only. I'll be coming on the second bit position. I'll be finding that 4 has occurred thrice. That means 1 has occurred 4 times. That means again this bit will be set of a number which has occurred only once. That means it's 1 and there's nothing but 5 only. So this was the logic, and let's see the code and discuss the time complexity further. So basically what I am doing is I am iterating over all the bit position from 0 to 31, and I will be checking if that bit is set or not. Like I am iterating and I am finding is that bit set or not. If it is set, I will be taking it in my count. Uh, and how I am checking it, simple. I am just using this logic, set bit logic. You can see it once, you can dry run it, it's easy. And if it has occurred in a multiple of 3, that means it should have been divisible by 3. If it's so, I won't be doing anything, but if it's not, then I will be setting that bit position on. And how will I set that bit position on? I can do that by using OR operation or XOR operation, and this is left shift operation. That means if the second bit would have been on, I want to on that bit. So what would have I have been doing is num initially supposing it to be 0 only. So 0 or wait a second, 0 or 1 left shift 2 will be 4. 0 or with 4 it will be 4 only. So I'll be returning answer as 4 in this case example. So yeah, this was the logic, and the time complexity of this approach is O of 32 into n, which is like constant only because 32 is a small number and I can ignore it. So the time complexity reduces to O of n. So yeah, that's all. I can run it again as well. So yeah, this is the approach. Thank you.